Okay, hello everybody. So we have already started with the trigonometry and we have understood what is the objective of trigonometry. So with that objective, first we need to know what are different types of triangles first. Okay, so you have already studied types of triangles in the subject geometry also. So you have triangle. Triangle is any figure which has three sides. Okay, any figure having three sides, it is called as a triangle. So this is a triangle, and now this triangle obviously it will have three vertices here. So these vertices are generally named like A, B, C, P, Q, R, or it can be X, Y, Z, or it can be as per your wish, you can name them. So I have named it as A, B, and C. Now these are called as the vertices. Okay, and so you will have side AB here, side BC, and you have side AC here. Now generally these sides are also named. Now if this vertex is B, then the side opposite to this vertex, it is generally denoted by B, small b. So small b is the length of this side AC now. Similarly, this side opposite to A, okay, which is BC, it is generally represented by small a, and similarly opposite to C, it will be small c. Now, and these angles are represented by these vertices itself. So this will be angle A, this will be angle B, and this will be angle C. So a triangle will always look something like this. Now these angles might be different and these sides might be different. Now depending on the value of these angles and value of these sides, there are different types of triangles. Okay, let us try to understand now. Now if A, B and C, all these lengths are equal. Okay, if A is equal to B is equal to C, what is the meaning of this? The length of this side AC, length of side BC, and length of side AB, okay, that is A, B and C, all are same. Then in that case such a triangle is called as equilateral triangle. So in this case this triangle will be called as equilateral triangle. Okay, now again, when we were discussing about the meaning of this word trigonometry, we broke that word in two parts like trigono and metry. Similarly here, it can be broken into two parts. One is equi, another is lateral. Equi means it is same, lateral means it is sides. Okay. So a triangle which is having equal sides, it is called as a equilateral triangle. Okay. So equilateral triangle here onwards I will be representing it like this. So small figure of triangle and AL as a suffix. Okay. Now this is one type of triangle. Now if only A and this any two sides of a triangle are equal, for example A and B or B and C are equal. So I am representing this triangle here now. Let us suppose this is triangle like this. Okay. So now easily you can make out here, this is to the two sides of this triangle, side C and this is B. Okay, B and C they are same, whereas this which is A, length A is different. So here we have B is equal to C. That means the two sides of a triangle are same. In that case, this kind of triangle, it is called as isosceles triangle. Okay. It is called as a isosceles triangle. Now it is very interesting fact there are related to these triangles now. Okay, equilateral triangle and isosceles triangle. Okay, in case of equilateral triangle we have this condition A is equal to B is equal to C. There is one more thing interesting factor, these angles A, B and C, they are also equal. Okay, so for equilateral triangle you will have angle A is equal to angle B is equal to angle C. Angle is generally denoted by this symbol. Okay, again you can see here this is the symbol for angle A. Okay, so angle A is equal to angle B is equal to angle C. Now the sum of internal angles of a triangle, it is always 180 degrees. Okay, so if I add this angle A, B and C, angle A plus angle B plus angle C, it is always equal to 180 for all the triangles. This rule is applicable for all the triangles, and I just write out here. Okay, this is for all the triangles. So whatever be the type of triangle, this rule will be applicable to that triangle. Now, if a triangle is equilateral triangle, then in that case, angle A is equal to angle B is equal to angle C. So obviously, I know you all will have that question in your mind. If they are equal, then the value of angle A, angle B, and angle C, it has to be 60 degrees. Right. So this is, I hope everybody can understand this, because the total angle, it has to be 180 degrees. If all angles are equal, then it has to be 60 degrees. Right. Now, similarly, in case of isosceles triangle, we have only angle B equal to angle C. Okay. So, sorry, side is equal to side B is equal to side C. Any two sides. Now, these two sides are equal in case of isosceles triangle. Then, in that case, this angle and this angle both will be same. That means angle B is equal to angle C in case of isosceles triangle. So these are some of the rules related with this isosceles triangle. Now there is one more kind of triangle in where all the sides are different. That means none of the sides are equal. If none of the sides are equal, then obviously none of the angles will also be equal. Okay. So one example here I am drawing here with a different colored pen now here. Okay. So you can have this kind of triangle now. Okay. So where this is A, this is B, this is C, and you have these opposite sides, that will be length will be A, this will be B, and this is C. In this case, A is not equal to B, is not equal to C. Okay, then this kind of triangle, it will be called as a scalene triangle. It will be called as a scalene, Scalene. Okay, scalene triangle. Okay, now although we have discussed about these types of triangle here, but we are not much concerned with this kind of triangles with trigonometry. We won't come across these triangles in trigonometry, but to understand the concepts of triangle, we have just seen this, we have recalled these properties of some triangle. Okay, now there is one special case about all this apart from these triangles, that is called as a right angled triangle. Okay, so in trigonometry, you will always come across a right angled triangle. Okay, now right angled means obviously you can understand. Right angle means it is always perpendicular to each other, or perpendicular to each other, it means the angle is 90 degrees. For example, I am drawing that triangle here. This is one side of a triangle. If another side of triangle is at right angle, okay, so this is called as the right angle. Okay, so that means these two lines, they are perpendicular to each other, and this is the third side of a triangle. So I am naming this triangle again. This is A, this is B, and this is C. So obviously the length will be opposite to this. This is the length A, this is length B, and this is length C. Okay. Now in this figure, you can say, you can see here this angle at B, it is perpendicular. That means it is 90 degrees. 90 degrees as it is represented like this. You can see here how it is represented. Okay. So this is 90 degrees. If this is 90 degrees, then the value of these two angles, how much it will be? The total sum of all the angles. So we have angle A here plus angle B here and plus angle C here. The total sum is how much it is? 180 degrees. Angle B is equal to 90 degrees. Therefore, you will have angle A plus 90 degrees here plus angle C is equal to 180 degrees here. Okay. So this obviously means angle A plus angle C is equal to how much? 180 minus 90. It will be 90 degrees. Okay. Now in a right triangle, okay, one angle will be 90 degrees and the sum of other two angles, it is always 90 degrees. So this is one of the important properties of a right angled triangle. Okay, this is one property. Now you might have heard of one more property, that is Pythagoras theorem. You might have heard of in your earlier classes also. Now if you apply that Pythagoras theorem here, then what is the Pythagoras theorem? It is if a right angle triangle, in a right angle triangle, if you have these sides A, B, C here like that, okay, and if this B is called as the hypotenuse, okay, this B is called as hypotenuse. I am writing here now A, B, and C. Okay, this side A here, this side A, this A is called as a adjacent side. Okay, it is adjacent side. This side B, okay, which is inclined, okay, this side B, it is called as hypotenuse, okay, and this side, okay, it is called as a vertical side जो है, it is called as a opposite side, okay, and this angle, it will be called as some angle theta, okay. Now if this angle is theta, if angle C is equal to theta, then okay, then only we can call A as the adjacent side, because this you can see this side जो है, this side BC or this length A, it is adjacent to this angle. It is adjacent means it is nearing, it is close. Okay, it is just neighboring like that. So that is why it is called as a adjacent. So it is this side is called as a adjacent, and the side which is opposite to this angle, okay, to this angle theta, the opposite side is this one. So it is called as opposite side, and this is called as the hypotenuse. Okay. Now in that case, if you apply that Pythagoras theorem, then that theorem says a square plus c square is equal to b square. Okay. What is the meaning here? A is what? It is the adjacent side. Okay. C is what? It is the opposite side. So it is sum of squares of adjacent and the opposite side. It is sum of squares of adjacent and opposite sides, that is always equal to the square of the hypotenuse. That is what the Pythagoras theorem says. So this is a Pythagoras theorem. Okay, Pythagoras. I think you have heard of this in your ninth standard also. So that is what we are. I'm not going much in details of all these things. Okay, but as and when required, we'll be again coming back to these theorems. Okay. Hello everybody. So in this video we are going to see about the another geometric figure that is called as a circle. In previous video we have seen triangle, different types of triangle, and one special case of triangle, that is right angle triangle, and what is the meaning of the Pythagoras theorem and how it is applied to that triangle. Up till that point we have seen. So in this video we are going to see what is the meaning of a circle and different terms associated with this circle. Okay, so circle actually it is a locus of points which are equidistant from one point. Let us suppose I am considering here one point O, and if I draw number of points which are at equal distance from this point O. Okay, so you can have number of points here like this. So you will have infinite points. Okay, all these points, they are at equal distance from point O. Locus of such points, it is called as a circle point. Now locus of such points means what? You will have infinite points. If I join all these infinite points, then it will be look something like this. So this may not be looking as a circle, but this is a locus of all points which are equidistant from point O. Okay, that means if I consider any point here, whether it is here, here or here, all these points P1, P2, P3, all these points are at some equal distance from point O, and that equal distance, okay, this equal distance, it is denoted as capital R, and it is called as the radius of this circle. Okay, so what is circle now? Circle is a locus of points which are equal distance from this point O. That equal distance is denoted as capital R, and this locus of points is called as a circle. So circle is any geometric figure which has a center and which has radius R. Okay, so with this we are going to again consider a special case of this circle. Okay, in which the radius r is equal to 1 unit. 1 unit means it can be 1 centimeter, 1 meter, or 1 kilometer, or it can be anything. Okay, so that is called as a 1 unit. Okay, so I am going to consider a circle with radius as 1 meter. Okay, so I am drawing a circle here. I hope this circle now looks like a circle. Okay, and let us suppose this is the center of this circle. Okay, I am denoting this center as center O. Okay, obviously we have considered this as unit circle. So the radius of this circle, let us call this as point P1, and this length P1, which is radius of that circle, that will be unit circle. That means it is 1 unit. Okay, so if I have a number of points, I can have number of points P1, P2 like that. Let us suppose I am having one point P2 here. Okay, I am having another point P3 here. You can have a number of points. Okay, now, if I join this point P2 here, okay, let us suppose this angle is some 45 degrees. Randomly, I have chosen that angle. Okay, so this is 45 degrees. Okay, now what I am going to do is I am going to draw projection of this point P2 on OP1, and similarly projection of this point P2 on OP3. So for that, projection means what? Now, if I look from this side, okay, if I look from this side, or if I put a torch here like this, okay, then the shade, okay, of this point P2, it falls on this line somewhere here. Okay, this is called as the projection. Okay, this is called as the projection of this point P2. Similarly, if I put a torch in this direction, okay, then the shade of this point P2, it falls on line OP3, okay, and it falls somewhere here, okay, then this will be called as projection of point P2 on OP3. Okay, now this OP1, you can see it is a horizontal line and this is a vertical line. Okay, now this angle is 45. Okay, now we have already seen in any triangle, right angle triangle, okay, if this is angle theta, then the side which is adjacent to this angle, we call it as adjacent side. Okay, and this side we call it as a opposite side. Okay, and this is called as the hypotenuse. So this is hypotenuse, this is adjacent, and this is opposite side. Okay, now what I'm going to do here is I'm going to consider one more point here. Okay, and I'm going to call it as a point P2 dash here. Okay, similarly here I am having a point P2 dash. P2 dash because a similar point I am considering here. Okay, and I am joining this. So this will be again 45 degrees here. Okay, so this angle is how much? It is 45 degrees. So now similarly this P2 dash will have projection on this opposite side also here. Okay, here also you will have projection of this point, but we don't need projection in this particular construction. Okay, so I have only constructed this much part, right? Now let us consider I am joining this P2 and P2 dash with a vertical line here. So it is with a light color, that is green color I am using here. Okay, so you have a triangle here now, O, P2 dash and P2. Okay, so let us consider that triangle. Okay, that's why I am drawing that triangle here. O, okay, so this is point O here I have drawn, this is point P2 and this is point P2 dash I have drawn here. Okay, now I want to compare these two triangles here. This is the triangle, a standard right angle triangle I have drawn here. This is also a right angle triangle. Okay, because here we have 45 degrees and this is 45 degrees. That means this angle will be right angle here. It is 90 degrees. Okay, now if this is 90 degrees, so it is equal to this line. Okay, in this figure also we have 90 degrees here. Okay, right? Now this is again a special case of right angle triangle. Okay, the thing here is, okay, this O and P2, okay, this line, this is equal to radius R. Now R in this case we have considered it as 1. Okay, so this is a unit circle now. Okay, unit circle, the meaning itself is the radius is equal to 1. So this OP2 is 1 and this OP2 dash is also 1 because it is isosceles triangle. Okay. Now, so this will be 1, this is also 1. Okay. Now this is a right triangle angle triangle. Now if you apply a Pythagoras theorem to this triangle, then what will happen? Okay. This sum of the squares of adjacent and opposite sides is equal to hypotenuse. That means OP2 square. Okay. So OP2 square, right, square of this, and OP2 dash square, OP2 dash square will be equal to P2 to P1 dash, that is square. So this will be P1 P2 dash square. Now OP2 square means square of this side. This square side is nothing but 1 square, plus OP2 dash means this side. The length of this side is again 1. So it will be 1 square. This will be equal to how much now? 1 square plus 1 square is 1 plus 1, that is 2. Isn't it? So this will be 2. Sorry, here we have square again. Okay. So what is this 2 now? P1 P2 dash and square of that it is 2. So this implies that P1 P2 will be equal to under root of 2. Isn't it? P1 P2 dash square is equal to 2. Therefore P1 P2 will be root of this 2. So that means this length is how much? It is root 2. It is root 2. Okay. So this length from here to here, it is how much? It is root 2. Now this OP1, it is bisecting this side P1 P2. So obviously from here to here, this will be root 2 here, root 2 half of this. That means it will be root 2 by 2 and this will be also root 2 by 2. Right? So I hope I am going correctly, right? So it will be root 2 by 2 and this also will be root 2 by 2. Okay. Now interesting fact here is, now you can see here, now what is this root 2 by 2 actually? If you see the basics of a trigonometry, then it says the projection of this point P2 on this horizontal line, okay, it is called as the cosine of this angle 45, and projection of this line, okay, this point P2 on this vertical side, it is called as the sine of that angle. Oh, okay. So this distance from here to here is equal to this distance. Okay. That means projection of point P2 on this vertical line is how much it is? Root 2 by 2. That means sine of this angle 45 is equal to root 2 by 2. So what is this sine of angle 45 now here? Sine of angle 45, okay, is equal to projection of point P2 on vertical. Okay, projection this much distance. Okay, if it falls here, it will be called as how much? Root 2 by 2. So this is equal to root 2 by 2. Yes. Now this is root 2 by 2. I can, this again it can be written in different forms. Now if I multiply this by root 2 again here, so you will have root 2 here and divided by root 2 here. Okay, so what will happen? It will be 2 divided by 2 root 2. Okay, so 2 will cancel each other and it will be 1 by root 2. That means sine of 45 is how much it is? Root 2, 1 by root 2. Therefore sine of 45 equal to 1 by root 2. Similarly, cos of 45 in this particular case, you will see that is also 1 by root 2. Okay, because this forms a square. So all the sides are equal. This side is equal to this side and this side is also equal to this side. Therefore, the projection of this point P2 on this adjacent side or the horizontal side, which is called as the cos, okay, cos of that angle. Okay, so cos of 45 is what? This is equal to projection of P2 on horizontal line. Okay, Again, this is equal to the same value. It is 1 by root 2. You will have to just look at the figure. Then you can easily understand this is equal to 1 by root 2. Okay. Now, this similar procedure can be adopted for different angles. You need to do some mathematics for that. You will have to multiply, divide some figures and all that. And finally, you will get sine of any angle and you can find out cos of any angle on this unit circle following the same. If you follow the same logic, same approach. Okay. Now, after doing all these things, then you can easily remember. We will just go see how to remember these values. Okay, how to remember sine of 45, how to remember sine of 60. Okay, so there are some standard angles for which we are going to remember. We need to remember the values of sine, cosine, and there is one more trigonometric figure that is called as tangent, which is ratio of sine and cos. Okay, so these figures we need to understand, and it is very easy actually. So I will just draw here one table. Okay, and using that table we are going to understand, we'll see how to remember the value of this sine, cos and tan. Okay, so let us suppose we have angles. Standard angles are 0, 30 degrees, 0 degrees, 30 degrees, 45 degrees, you have 60 degrees, and you have 90 degrees here. Okay, now what I'm going to do is, here I'm writing down sine. Okay, this is cos. Cos means it is cosine, and then I am writing here tan, that means tangent. So tangent is nothing but it is the ratio of sine and cos. So tan equal to what? Sine divided by cos, and we'll see how we get the answers. Okay, so I am writing here now 0, 1, 2, 3 and 4. Okay, now divide this by all these figures by 4. So I am dividing this by 4 again here. Okay, and take a root of all this. Take root of all these figures. Okay, so 0 upon 4 it is 0, and root of any 0 is again 0. That means this is what? 0. So sine 0 means it is always 0. Now this is 1 by 4 and root of that. That means root of 1 divided by root of 4. Root 1 is always root only 1, and root 4 it is 2. That means this comes out to be 1 by 2. So it will be 1 divided by 2. Okay. Similarly, root 4 here it is 2, and this root 2 remains as root 2 itself. Okay. So it will be, I am just simplifying here now again. Root 2 divided by 4. Okay, divided by root 4, this will be root 2 divided by 2. Again I am multiplying by root 2 by denominator and numerator, so it will be something like 2 divided by 2 root 2. Okay, so 2 gets cancelled and you will get it as 1 by root 2. So I am replacing this by 1 by root 2 here. Okay, so similarly here it will be root 3 by root 4, that root 4 is nothing but 2, so it will be root 3 by 2. Okay, 4 by 4 is 1 and root of 1 is again 1, so this will be 1. So you can just rewind your video and you can very easily understand how we have got these figures. Now whatever the figures I have got here, all these figures I am writing in the reverse direction now. We are writing in this direction, now I am going to write in this direction. So it will be 1 here, root 3 by 2 here, 1 by root 2 here, and you will get 1 by 2 and you will get 0 here. Okay, now the meaning is sine of 0 is 0, sine of angle 30 is 1 by 2, whereas cos of 0 angle is 1 and cos of 30 is 1 by root 3 by 2. Okay, you will find here at 45 degrees the sine and cos, they are same. Okay, sine of 45 degrees and sine cos of 45 degrees, it is same, and it is 1 by root 2. Okay, now finding tan, it becomes very easy. Tan is what? It is always the ratio of sine and cos. Sine divided by cos. So sine divided by cos means for 0, angle 0, it will be 0 divided by 1. That means it will be 0. Okay. Now 1 by 2 divided by root 3 by 2. So it is 1 by 2 divided by root 3 means it will be 2 by root 3, isn't it? So 2 gets cancelled and you will get 1 by root 3. So this will be how much? It is 1 upon root 3. Right? Now similarly here, tan of 45 is sin 45 divided by cos 45. Sin 45, cos 45 are same. Therefore, the ratio of sin and cos, it will be equal to 1. Okay. Now, for 60 degrees of angle, sin 60 is root 3 by 2 divided by 1 by 2. That means multiply by 2 by 1. 2 gets cancelled. So, you will get only 3, root 3. So, it is root 3 here. Okay. And tan of 90 degrees means sine of 90 divided by cos of 90. Cos 90 is 0, sine 90 is 1. That means 1 upon 0, it comes out to be infinity. Okay. So this ratio at 90 degrees, the tan will be infinite. It doesn't have any value or set as such. Okay. So you can easily remember these values. If you don't, we have seen how to find out these values of sine, cos and tan at important angles. Okay. And the important angles for us are 0 degrees, 30 degrees, 60 degrees and 90 degrees. Okay. So you can just rewind the videos and see how to find out these angles again. So with this, we'll stop here today. Thank you.